We went through this last time, didn't we?
What do you mean?
Oh, I'm good. Good morning.
Hi, sorry. I'm just trying to get everything set up here.
Who is this?
It's Ashley. I'm gonna rechange my name.
Oh, okay. You're with ATS, obviously.
Yes, I'm on the marketing team and I just basically get the Zoom all set up, ready to
Oh,
record.
okay. Here I'm talking to myself because it's Stuart Seville.
Oh, hi.
Zoeller. Yeah, no, I was because anytime Zach goes on, he says, Stuart, you got to unmute yourself, and I'm going, oh, where's my unmute button? But you can obviously hear me, so I'm okay. That's why he said.
Hello, Stuart.
That's why I said what I said. You're lucky I didn't say what I normally say to Zach. Ashley, you might be you might be calling.
No, I sit
you
here
might be
quietly.
calling HR.
I sit here quietly. I say nothing.
Oh, okay. I thought maybe I might hear the call. HR, we got a problem.
No, you're fine.
Okay.
Zach, just let me know everyone you need me to promote for this.
It would be Stuart, myself, and Mo.
Okay, perfect.
And then Stuart will have the ability to share your screen.
All right, so perfect.
So Stuart, you should be able to share your screen now.
Okay, that's why I was. There we go. And I think I've just shared my screen with you.
Yep.
Okay, that's good.
So you're on presentation mode.
Is that what you want?
Perfect.
That is okay?
No. Click that button that you were on, and then it'll be perfect. Premature perfect.
There you go.
There you go.
Okay.
Perfect.
Okay, perfect. All right, excellent.
Okay, Mo is here too now.
So Zach, how many people you're anticipating?
We should have, I believe, around 50 or 60.
Holy smokes. All right. Now the key will be to see how long we can keep them on.
I think people are pretty interested. They've been and spending the whole time with us.
What's the diversity of the group like?
Pretty much all engineers.
So all mechanical or electrical or?
I would say they're almost all mechanical.
Okay. And are they from firms that we've talked to previously, or are these all different?
It's a wide variety. There's some firms that we've talked to previously, and there's some that are maybe haven't had a full lunch and learn from you on this subject yet.
Okay.
Like I know there's a lot from AREP.
So are they, are most of them working off-site, or are a lot of the engineering firms continuing?
No, all the engineers are working off-site.
Okay.
There might be the occasional one that heads into the office, but I don't believe that would be few and far between.
Okay. Good morning, Mo. Oh, he's not there.
Morning, Stuart. How are you doing?
Oh, good. How are you?
Good.
Yeah. Are you guys finding enough to keep yourselves busy, or you're doing a lot of this type of thing, the virtual learning and reaching out and?
We're doing this once a week. I think the rest of the week we're pretty busy with requests.
No, that's good. That's good.
How's the weather looking for all of you?
Well, I'm in Port Credit, just out this southern part of Mississauga, and it is overcast. Was raining earlier today, so
Yeah, it's about the same here. It's kind of gloomy. Yesterday was beautiful though.
yes, it was a nice day. Now, Zach, there was somebody else in your office reached out about a week ago looking for a controls seminar, an internal control, electrical control seminar.
Oh, that would probably be like Richard or Kristen.
I was trying to think who it was now. And I think it was just on a lot of the basic understanding of control panels application.
Yeah, I would imagine that's probably our spec team and our quotes team that
Yeah,
are looking just for
and
additional training.
I didn't get back to him because I'd have to work. I have to kind of build one up for him, but I'm sure it can. We can do it with. Let me just see if I can find on my phone.
That's all right. We can go over that later. And hello to those that are with us early from the different engineering firms. Thanks for joining us. We're just getting a little pre-discussion here, and we'll get started around noon. Thanks for joining early. Hope your day is going well so far. Hello, Dave. How are you?
Who's this, Zach?
Yes, sir. How are you?
I am well, man. How are you? Are you still keeping up with the quarantine?
Keeping up with the quarantine. I got a little bit of a break this weekend, which was very nice. The girlfriend was I only get to see her after she's off from the hospital 4 days. So
Oh, she's working in the hospital?
Yeah, she's a nurse at Toronto General. So
Oh my
I got
gosh.
to hang out with her on Saturday, and we had our first date night in about 2 weeks. So that was
Sorry,
nice.
you have what?
We had our first date night in about 2 weeks, 3 weeks, something like that.
Well, I hope you were a gentleman.
Of course, we made chicken pot pie. We played board games online with a bunch of our friends. So
That's great. That's good.
we even made dessert. I have no idea that making like pie.
Can't hear you very well,
actually
Zach.
very
You
easy.
keep kind of wobbling a bit.
Yeah.
I guess I'm the first one in, am I?
No, there's a few people that are getting in here. We'll wait for a few more to get settled and the call. Just want to say hi.
Zach, you keep cutting out a bit. I'm not sure where you're located in your house, but
It's just my Wi-Fi is pretty bad.
okay, just letting you know.
I appreciate it. Tried to have the IT guy fix it up this weekend. Clearly did not work.
Have you made the virtual sandwiches and cookies, Zach?
Yeah, they're on their way over to you now, Dave.
Okay, very good. My machine accepts cookies, so
Yeah, you got some Dad's oatmeal chocolate chip right next to you.
oatmeal, did you say?
Oatmeal chocolate chip, those are the best cookies.
Perfect.
Well, good morning to those that are just getting logged in. We'll wait
morning.
for the others to join us, and we'll get started in 5 minutes. Just as a heads up, we do have most people on mute, but of course, welcome to ask questions during the conversation with Stuart. You can either unmute yourself to ask a question, although we do have a Q&A field. If you go down to the bottom of your screen, you'll see the Q&A field and the chat field. You can submit your questions there as well. Thanks for joining us. And good morning to all those just logging in. Again, just as a heads up, we'll have everyone muted during the conversation. You can definitely unmute yourself to ask any questions along the way. There's also a QA and a chat field down below that you can submit your questions in. We'll get started just in a few minutes. Thanks for joining us. Alrighty, and I'll just check in with Stuart, make sure you're there and good to go.
I am here, Zach.
Perfect. Well, thanks for those that have joined us. We'll kind of get started with the introduction here, as I'm sure a number of people are still kind of moving over to get logged in. I know I understand I've got some internet issues this morning, so I'll keep my portion brief and pass this over to Stuart. Just as a quick reminder, anyone can go into the QA field or the chat field and submit any questions along the way. Stuart's been with Zoeller for a number of years, and Zoeller has been a supporter of ATS for over 5 years now. So we're very happy to have them and very happy to put together this system design presentation that hopefully will be of good assistance during your quick turnaround projects here. So Stuart, I'll pass it over to you.
Okay, good morning. My name again is Stuart Seville. I'm with the Zoeller Pump Company located here in Canada. So I'm really glad that you were able to get with us today. Typically, we'll do a lunch presentation with ATS. So I'll be moving back and forth and using a lot of visual, a lot of hand motions, trying to describe things and make things easier. So in this presentation, you'll have to excuse, but I've taken the liberty of doing a lot of arrows and a lot of circles just to kind of emphasize some of the points I'd like to make in the presentation. In this very quick agenda, and again, I've trimmed it down to coincide with perhaps a lunch hour so that we don't leave you all sleeping in your chairs or grabbing a fork or a knife and trying to keep yourself awake. So I trimmed it down somewhat from what our normal presentation would be, but I want to just go through brief history, some unique features of the Zoeller pump, basin sizing and pump sizing, which is something in general that you may find of interest or of help. Talk about location and access of pumps, which is another point which is unique to the Zoeller Pump Company. We also have a controls company, so a kind of a unit responsibility that we can give you in when you're using our product. We can also give you a control panel. So I want to just briefly go through the specifying the controls. And at the end, again, hopefully if Zach's internet connection, he'll probably want to just talk about the ATS and the Zoeller partnership as we go forward. So again, thank you very much for being here. Zoeller Pump Company is a family-owned a company. It was founded in 1939, so obviously we're in our 80th year. We have our fourth generation is currently working in the Louisville facility. We have over 700 employees in the US, and we have manufacturing and distribution locations around the world. We're in about 4 or 5 different different countries. Zoeller Canada came about in July 1st of 2007, and that's when I joined the company. I was the first expat, I guess you could say, to join the company. Prior to that, it was all US people. We incorporated at July 1st of 2008. Now we own our own 135,000 square foot facility in Brantford, Ontario. And we did that in 2017. And we ourselves are 90 employees in Brantford. And I just, there's a gentleman there with what we would call a column pump. That's Pop Zoeller. He was the first generation. And so he was manufacturing pumps. In 1939, he manufactured 5 pumps and distributed them in the back of his station wagon to some local distributors. And this year, being our 80th year, we're going to be making our 20 millionth pump. It's going to be coming down the line very shortly. So again, on the right-hand side, we're just showing you some of the facilities and some of the manufacturing and storage facilities we have down in Louisville. The Zoeller submersible pump is essentially, if you were to take that picture on the right and turn it on its side, it would look or behave very similar to a centrifugal pump. A centrifugal pump being used on a cooling system or a booster system or a fire pump, that sort of thing. The difference being that it's hermetically sealed, so it can be submersed in water, and we enhance the capability of the operation by filling it with non-toxic transformer oil to minimize a lot of the heat that is created in these pumps. So again, it is submersible. So the key fact is it's going to be down in the water, wastewater. We have standard hazardous duty from 0.5 horsepower up to 60 horsepower. We have water, wastewater, dewatering, and solids handling. So again, we have the utility small effluent pumps, which are typically 3/4 inch solids up to the 2 horsepower. And we go up to 4-inch solids handling right up into our 60 horsepower. Grinder pumps, which are becoming more prevalent in a lot of applications today, and we'll talk about those later on. We go up to 7.5 horsepower, standard and explosion proof. One of the key features that we like to harp on and like to indicate is because we are a true pump manufacturer in the US, where we do machining and things like that, every pump is 100% wet pit tested and verified. So it's stuck in the pit and we do the whole performance regimen on it, every one of our pumps. Again, the Zoeller, we design, we engineer, and we build. In the bottom right-hand corner is a typical performance test that we perform on our units. And we'll go through 4 or 5 points of operation, no different than a centrifugal pump, but it's in the pit. And what you do is you create different resistances in the application or in the setup, and then you take electrical performances, and from that you can you have a good record of what's transpired in the build, and also what's going out in the field. And also that's a great representation and tool for us in the field, that if you ever have an issue or questions about the performance of our pump, we can go specifically to the performance audit or the performance test that we've done on that unit. This picture represents the 2 extremes, I guess you could say, of the Zoeller. On the far left-hand side is the pump that most people might realize or symbolize the Zoeller pump company, and it's a 1/3 horsepower residential sump pump. That particular pump weighs about 25 pounds, all cast iron. And on the right-hand side, we have up to our 20 horsepower, that's about a 200 or a 475 pound pump. But the same engineering and design criteria that we use on the left-hand side with our 53 is the same what we do is on our large HD series, which goes up to the 20 horsepower. I've got 2 red arrows there indicating, the top one is indicating where there's a switch mechanism for that particular, that pump there's a white float just on the right-hand side of that pump. And as the water would rise, that float rises, and then there's a switch in there that turns the pump on. So again, just to indicate to you and show you that particular switch is in a dry cavity above, and where the second arrow is the body of the pump. So we've isolated the 2, the switch from the actual body. Now this same design feature we carry it on to our larger pump, and I apologize for all the arrows, but again, this is where you would have me running around the room trying to visually show things to you. The red arrows on the far left-hand side represent the different portions or parts of the pump. And again, I've put some bold red arrows there just to show you that the product is entering from the bottom of the pump and typically is discharging off to the right there, or vertically if it's a vertical discharge pump. So the green arrow that you see on the left-hand side, that's just representing showing you the separation of the actual cable assembly, which comes in at the top of the pump, how it is separated from down the next section down, which is the motor housing. And again, this is how we build our pump. We build it in it's a modular build. And with this design, it also enables us to field test this pump. If there's ever an issue with our pump in the field, we don't have to take the pump out and completely disassemble it to try to analyze what could be the issue. We can go down from the cable assembly down to the motor, down to the seal chamber to figure out what's transpired and what's happened in the field. So it gives us a good chance to field test. In the middle, again, I've just isolated specifically on the motor housing and how it is separated from the upper portion being the cable entry. So that's where your power would come down to those terminals, and then the wires from the motor come up to that terminal plate. So again, they're isolated. The key is with all these particular sections that we put together in a modular form, we're pressure testing them and air testing every one of them to ensure that the integrity and the seal is maintained. On the picture on the right, that shows you the motor, how it is embedded, which is important. It's embedded in the cast iron finned housing. And again, this is a way of ensuring that we've got a way to dissipate the heat. In any electrical appliance or machine, there's going to be heat that is generated. So we need a way to minimize the effects of that temperature rise. So that's one of the keys with the Zoeller, is we've embedded the motor. It's right into the cast iron, and that assists in how we dissipate the heat from the application. Now, again, just very quickly, I've noted NEMA B and NEMA F motors. This is This is important because we have different motors for different applications, and these motors are, we do numerous tests on how they behave or function under test for like 20,000 hours. So this is another way we can ensure that we're getting the right motor for the right application. You'll have continuous duty and you might have intermittent duty applications. So thus you'd have different types of motors. And again, there's a lot of temperature that is being generated, and it's not only from the operation of this pump. You can also have temperature rises in like spikes or surges in the power that is being supplied. You can have temperature just from the actual application if you've got a high head application or you have a low head application. So again, these design features assist in isolating the heat and also minimizing how the effect it's going to have on a lot of your components. This is a picture that I don't always like to show, but it is showing or illustrating the popular motor housings of a lot of other manufacturers in the industry. If you notice in our particular, again, our slide, we've got our motor on the right-hand side. It's embedded into the cast iron housing versus down here in this particular picture on the left-hand side, you can see that that is just the look of what a standard NEMA motor, centrifugal motor you'd have on a pump that has the stator there, and then it has an outer shell. And then typically what they'll do is just put a motor cast iron housing over top of it. The problem with this particular design is that you're going to get, and on the left-hand side again in yellow, I just illustrate the aluminum end bell that you see at the end there versus when we do our cast iron construction, we have a cast iron end bell. And there's a lot of heat being generated up there because there's a bearing. So again, it's just another way of differentiating ourselves from the typical build. On the right-hand side, you can see the electrical components on these two particular right-hand pictures. Both their electrical components are mounted right on top of the motor, which is right on top and in the motor housing. So again, we've separated the electrical components away from where the heat is going to be the most dramatic. This is, I'm just showing you the difference. You'll often hear someone talk about hazardous duty or explosion-proof pumps. Standard and explosion-proof pumps will have the same electrical performance and the same performance head and flow as the standard. So they are the same, whether it's a standard or whether it's explosion-proof. The difference is in how we manufacture the unit. And again, if you look at the two, one's called standard on the left-hand side, one's a standard and one's an explosion-proof. And as you'll see, there's just there's more machining on the cast iron of the explosion-proof. And then on the right-hand side, I've tried to circle, and you might be able to see where that machine creates a sort of an overlap. And that is to prevent the pump, if it ever was to explode, it literally would have to implode because there's no way for the flames or sparks to leave that particular cast iron housing. Okay, so that's just wanted to show that differentiation. So sometimes the particular explosion-proof pump profile-wise might be slightly higher, but not much, as you can see from those two cast iron pieces. And again, on the right-hand side, I wanted to show, again, our electrical components are separated from the motor housing. And by the way, Zoeller is the only pump company that has single-phase sump and sewage explosion-proof pumps in an automatic configuration. So why is pump sizing and selection important? This is key when we're talking about a lot of applications, and it's again, sorry about that. It's again, we talk about this, and a lot of this is taken for granted, but we continually need this information, and ATS will be asking you this information, and you should be asking your customers this information. It's going to save you a lot of time and a lot of effort going down the road. It's key for you to know what is being pumped, where are you going to be pumping it, where's the discharge location. Voltage is critical. You need to know your design condition and what you would be able to accept as an actual requirement. You have to know your control parameters. You want to know area classification. Now with a lot of applications are being deemed as being hazardous duty or explosion proof if the building contains people or if you're using hazardous material. And one of the other key points, is this a new or a retrofit application? So these all points seem very obvious, but unless you have this, you're going to spend a lot of time going back and forth and maybe readjusting what you initially thought was an excellent selection. You need to know these parameters. What we're trying to do with the ATS and the Zoeller is we're trying to build a system. On the left-hand side, you just see a typical pump. It's sitting in a container. Could be a fiberglass, could be a poly container. On the right-hand side would be more of your typical larger commercial, industrial, or even municipal application where you're dealing with a concrete basin and you have to put all the components inside. So we're trying to give you all the individual components to make either a package system on the left or a larger municipal industrial project on the right. We can go from small packages. The top left-hand corner, you can see a small white basin under a sink. This enables you could put literally a kitchen or a coffee room in any part of the building, and you've got your small tank underneath the sink there with a pump in it, and that would discharge over to your standpipe. So we could do small packages like that, again, representative of our drain series. The bottom left hand, you can see everything is very tight. We've actually got the pump and the check valve within the small tank, and that's like 11-inch diameter by 17-inch high tank. To the one right beside it where we actually have the check valve external. You may want to have access to that particular check valve if you're worried about product leaking or when you're doing the service work. We can do on the far right-hand side, we actually do large fiberglass tank packages with the pumps already pre-assembled on a rail system. So again, there's a variety of packages available, and we can do anything from, as I said, 11 by 17-inch right up to large 72-inch by 6 or 7 meters depth. I threw this one particularly in because this is something that's becoming more popular in a lot of applications. If you're working with your industrial clients, commercial clients, and they don't own the building, but they want to rent the building. And let's say they have a warehouse or a storage facility and they want to put a washroom in at the far end of the building so their people don't have to migrate up to the front to use the washroom in the front. This particular installation eliminates the necessity of busting up the floor, and you can put a toilet right on the floor, and then there's a grinder pump located directly below. In the bottom right-hand picture, I show the tank just below the toilet, or you can have in the middle there, you can see the tank is actually recessed in the wall behind. And the clear picture on the top left just shows you that there's a small 0.5 horsepower grinder pump in there. So literally it's going to take about 3 flushes of the toilet before that particular pump would kick on, and could pump literally up 27 feet in the air before it discharges. So that's a nice little retrofit package. Again, we've been putting them into a lot of construction trailers where again it's a mobile unit. So one of the big issues you're going to have when you're doing any design work is you're going to have design versus actual versus the design. And you've got anything from the left-hand side, the plumber's nightmare. This was a particular job where supposed to be very, very simple, was TTC job, and we're just going to put in a couple of pumps, and we get to the mechanical contractor gets to the job, and he goes, "Oh my God, this thing is filled with all this this pipe that we didn't know about." So here's the issue where perhaps the engineer and ourselves didn't do due diligence and actually look at what was actually in this particular facility, because we ended up very, very simple application became a bit of a nightmare for the contractor. The two pictures, the picture in the center and the picture on the right, illustrate what the original design was. The one in the middle was a large sort of a stormwater washdown application out in Calgary. And we sized up the pumps, and one of those pumps is the one that's the silver is our pump, and the one above it is one of the original pumps. And we sized the product up for about 10,000 gallons an hour, not a problem. And as we're doing the test run, the picture on the right represents what actually happened. All of a sudden, we had this huge inflush of water from a neighboring building. And the people at site said, "Oh yeah, we forgot to indicate that we're getting about 2,500 to 3,000 extra gallons an hour occasionally." So again, this is something some things you've got to ask is what's the actual versus, what's you're designing for. You've got to have the ability to coordinate and accept those things. So again, ask up front, are there any external amount of water coming into this facility? It's just do your due diligence. Here you've got existing site conditions that you're going to have to take into consideration. And it goes back to those original questions. It never hurts to ask all the questions up front. On the left-hand side, we're showing the results of the higher percentage of debris that is migrating down into the water, wastewater. Processes like this usually take it out in the screening and the clarification of sewage, of water, wastewater. But again, this is something that's becoming more prevalent in all the applications. On the right-hand side, here's a perfect application. We were told we were dealing with washdown. So again, it was a high head application. We put a grinder pump in. The only problem was the grinder pump ended up emulsifying all the product, and we ended up with a huge bin of, this was at a Nestle's, we ended up with a huge basin full of cookie dough. So again, clarify what's washed down, know your application. This is something, again, I threw this in when I came across it, and it's going to be becoming, again, more, as I said, more prevalent now with all the concerns about health and safety. You're going to find a lot of your applications that typically were very easily considered as to what type of pump you're going to use. You're going to have a lot more solids handling, non-sewage debris migrating down into your water wastewater applications. So be aware of that. And it's to the point where here's a perfect example of the Alberta Capital Region Wastewater Commission, which is representative of a lot of the smaller municipalities outside of Calgary and Edmonton. They have an association where they sort of control how they handle their water, wastewater. They felt it was important to put out this little 6-page brochure, and I thought I would just take a picture of it, because this is what's happening in a lot of the municipal, industrial, and even residential applications where all this non-sewage debris is coming down. So you have to be very aware of that when you're talking about your application. With that in mind, what I wanted to point out was, because we're getting a lot of non-sewage debris migrating down into the water, wastewater basins and septic systems, we have on the right-hand side, we have grinder pumps, and this is the 0.5 horsepower to the 7.5 horsepower configurations that we have. We also are the only company with a reversing grinder pump. And every alternate cycle, the pump works in the full cycle in the opposite direction. So it's minimizing clogging and minimizing the wear and tear on the cutting mechanism. But you're dealing with a grinder pump that typically is running at 3,500 RPM with its cutting mechanism and the number of holes. You're getting over 70,000 cuts per minute. So as you can see, this particular product is becoming more prevalent to handle all the non-sewage. On the left-hand side, you can see the difference. This is this is very similar to a competitive product or a popular method of where they have the actual cutting mechanism inside of a braider bar. So it's more like a meat grinder versus on our right-hand side, our cutting mechanism is working on a steel plate. So it's more evenly cutting and less chances of getting clogged. Just to kind of show you what we have in illustrating the grinder pump. This is a half horsepower grinder that we use in our residential applications, and you can see by the number of holes there. It's quite easily handling a lot of the debris. You'll see here that what can transpire. Now those were shop drags going in there. You'll see that even though there appears to be clogging happening because of the number of holes and the size of the holes, you're going to still be able to pass product and water outside of the system. I don't know, you shouldn't be getting that. I'm getting it.
Hey, Stuart, just to interrupt for a second, your mic is cutting out.
With it, I apologize.
No worries, just letting you know.
It's
Okay,
like
so
the,
you
the
didn't hear me
video
swear. That's
is
good.
slide.
Okay, so this particular unit is just grinding everything up. And again, this is a half horsepower. This would be your residential. We go down to a half horsepower. And then
Stuart,
up to
maybe
7.5
stop the video.
horse. I'm sorry?
Maybe stop the video because that's likely chewing up bandwidth.
Oh, okay. All right. All right. So I've shown the video. I apologize. I didn't realize that my audio was off due to that. But again, that shows you that even with the number of holes, gives you the ability to still pass fluid as you're grinding it. So you are going to it's important to have large holes there. So our particular design, we're getting about 15-20% more solids handling than a lot of other pumps in the marketplace. So that was one of the keys. Another one of an application that might be coming up that you're dealing with elevators, and you need to ensure that you're not pumping any hydrocarbons, any oil residue out from the elevator pit. So this is again something unique to Zoeller, where we have a oil sensing on the right-hand side. You can sort of see the setup where you would have your pump and you would have your controls mounted on a float tree. And essentially what happens, there's a pump float that differentiates between oil and water. So as it senses oil, which is usually riding on the top of the surface, it will identify that there's oil and will not let the pump. But as soon as more water comes into the pit and rises above the sensor, then the pump will allow the pump to come on and pump down till it senses oil. In this application, it's going to be sending an alarm to your building maintenance, telling them that they do have an issue in the pit, but it's still going to function as a sump pump. So again, that's another solution for those elevators that you have to work with.
Hey, Stuart, just
Yeah.
a quick question coming in from the group here. In regards to grinders, is the grinder, the plate separate from the pump impeller?
It is on the same motor shaft, and it sits below the impeller. So if you could go back to one of the original pictures of that little sump pump, there was a vortex impeller, or there was an impeller in the bottom of the pump then that motor would have an extension of her shaft, and this is where you would attach the cutting mechanism and the plate. So this is sitting below the impeller. So it's chewing up the product into about a 1/4 inch, 16 inch of a slurry, and then the impeller is moving it on, the vortex impeller. So I trust that answers that question.
Perfect. Thank you.
Okay. When we're talking about pumps and basins and containers, as we talked about earlier, there's ATS and ourselves go through a certain process in order to size up a basin or a container. And this could be square, it could be round, it could be a poly, it could be existing concrete. But this is important for you go through this sizing process, and we can do it for you, and we do it for you, is we want to ensure that you're getting a properly sized basin relative to the application and to the size of the pump you've obviously chosen or you want to choose. So one of the key factors that we will typically ask you is where the inlet location is coming. It doesn't necessarily have to come in from the side, but I would say 90% of the applications, the inlet is on the side of the tank, or it could come in at the top. Because this particular location now differentiates what you have as potential working volume versus what you have as lost space. So as you can see, anything above the inlet is now considered lost space. There's nothing you can do with it, because as water rises to that inlet, the last thing you want to do is have water going back in through the area that it just came in from. So again, the inlet location and then the area above the inlet is wasted. And then what we do as a manufacturer, we want to take a portion at the bottom of the tank to ensure what we call minimum submergence. And minimum submergence is a way to ensure that the pump, being a submersible pump, is immersed in water and will dissipate the heat that it's creating. Also, that you don't want the pump vortexing. If you can visualize a toilet bowl, when you flush the toilet bowl and you get that vortexing effect. That's what we don't want to happen, because that is when you start drawing air into your discharge and you potentially could cause issues down the field. You could get airlocks in between valves. You could get a lot of harmonics where every time the pump is operating, all the people here in the building is they hear the loud noises coming from your submersible pump. So the idea is the minimum submergence for a manufacturer, and we're not the only one, every submersible pump manufacturer is going to want a minimum submergence. So you lose that as your potential working volume. And again, working volume, typically we would like, and this is again all in the wishful thinking of a designer, we would like to have about 3 times what you want as your GPM. So if you pick a pump that's operating at 50 gallons a minute, we're going to design it potentially size-wise for about 150 gallons a minute. It may seem overkill, but it's better to have that allowance up front, that assurance that you've got enough to handle the inflows and also get a good cycle time out of your pump. All right.
Stuart, a couple of questions coming in from the crowd here, and they really tie to working volume. So one was, and you kind of just addressed it, what's the run time that you want to see? Which obviously, we're looking at 3 times the pump.
That's a good design. That's a good design for a pump, but it doesn't mean you can't have the pump run for a minute. It's just that, again, going back to, is it a continuous duty? Is it intermittent duty? And minimizing the stress on the motor. The longer the cycle time, the better, because the short cycles, you've got voltage spikes, you got surges, which are hard and detrimental to a motor. Also, if the pump hasn't had a chance to come up onto its start run, off its start windings and into its run cycle, you're going to have the pump running at a higher temperature. So the longer it runs, the temperature sort of evens out. So yes, we will size it for 3, but it doesn't mean you can't run a pump for 15, 20, 30 seconds. You know, we have residential sump pumps that are located around Lake Ontario that operate every 10 seconds. You know, we beta test that particular pump for 350,000 cycles. Or our 5-year pump, we beta test that for 1 million cycles. But it's just the nature of the beast. The pump is going to last longer if you have good cycle times.
And I guess along those lines, the other question was in regards to overloading. So the pump curve that Zoeller publishes, are the pumps designed to be non-overloading throughout that entire pump curve?
Our design criteria, and again, I didn't include one of those curves, but you're right. All our pumps are all sized for non-overloading anywhere on the curve. So if you size the pump at its best efficiency point, which typically is in the middle of its curve, and all of a sudden the pump is now running over onto its worst case scenario, well, all of a sudden there's no resistance, it's just churning water. The pump will generate heat, but it won't overload. The amp draw won't exceed what the nameplate is. So yes, our pumps are non-overloading in any location. And that's why one of the phrases we used to say is our pumps had power to spare. And that's true, because then there's certain design criteria where we may oversize an impeller if we know the application, and it's because we've got the extra allowances in the motor included. All right.
Thank you.
So those are your 3 sections. You've got your inlet location, you've got your loss space at the top above the inlet, you've got the working volume that we as a manufacturer are going to take. So if you can just visualize, let's just say this was a 96-inch basin, you've lost a couple feet at the top. I've taken maybe 18, 24 inches at the bottom. You can see that your working volume isn't as large as you anticipated. So again, these are wishful design criteria, and we can work with you if you've got a situation where you can't get that large of a tank, or the tank isn't that large just due to the issues. Well, there's ways of getting around it, all right? We may size the pump to pump out fewer gallons over a longer cycle, all right? Now, again, you could go through all that sizing criteria and then realize the pumps you've selected don't fit into the tank. So again, it's good to know what pump you're looking at initially, and this might dictate what minimums you need automatically. Here on the right-hand side, this duplex 4-inch pump requires minimum 60-inch diameter, versus you've gone through your whole sizing criteria and figured, oh, I can get it down to a 48-inch. So you need to know the type of pump you're looking at, the existing discharge pipe you're working with, or the pipe you're going to design for, and then size accordingly. And again, allow for extra equipment like ladders, platform. You may want meters, flow meters in there, or valves, bypass valves. You may want a platform. All right. This is kind of the picture we're going to end up. You know, we go through all your design. This is more of a municipal based. These are a couple of jobs we did on the left-hand side. You can see the tank. We've got a platform. We did something very, very similar to this in Black Creek at a large residential application. It was a fairly large tank, but it only had a couple little small 2-horsepower grinder pumps in it. But again, they wanted access ladder, platform. On the right-hand side would just be a concrete application where we've, no, I'm sorry, this one is also a fiberglass that we've put in. Just giving you 2 different. So those are drawings that we could come up with. You come up with the design criteria. We can do up a drawing. You can have this in your file for the project. and at least have an idea of what you hope will end up at site after it goes through the contractor bid process. Again, when you're talking about tanks and basins and containers, you've got to make an effort in your verbiage that you indicate what kind of cover you want. Do you want a solid? Do you want fiberglass, steel, aluminum, cast in place, pedestrian rated? Do you want it traffic rated because you've got vehicles, parking vehicles? You've got to stipulate this in front, because if you don't indicate those minimal criteria, you're going to end up with a wide variety of covers for your particular application, and you're sort of at the loss, because it's the contractor has deciphered the minimum information you've given, and will supply what he feels is best. Here's two examples. On the left-hand side is a gas tight. There's no, as you see, there's no holes or ports or inlets going through it. And we have a small square inspection plate there. So this would be a gas tight. This one might be something you'd see within a building. And on the left-hand side, we have the typical hinged non-skid cover with this one's just showing a vent. So there's different varieties, different applications. This is a typical hinged access. You might see this more in a municipal or industrial project. On the left-hand side, showing again a safety grate. This is when you open up the hatch, and in case you've got people wandering around, the safety hatch or the safety grates there can be put in place to prevent anybody from falling in or any tools falling in. This is what we're trying to get away from. If you do not stipulate in your project verbiage what type of cover you want, this is what you're going to get. This is the contractor's favorite. It's called a curb, frame, and cover. And it looks great when it's first put in, but it's got, this particular one might have 15, 20 bolts around the perimeter, have all the right gaskets in initially, but the first time they go in to service it and the contractor has to undo all those particular bolts, they are not going to go back on when he leaves, because he'll use the excuse, oh, I have to come back, or he'll drop half of them into the tank in error. And this is what you end up. You end up with a insurance nightmare, and this is not good for the owner. Can you imagine this a couple of years going back and the owner trying to figure out what's in this pit, and he goes to the drawings and sees your engineering drawings on the side and kind of wonders whose idea this was. So again, the circle represents it's missing gaskets. The lower arrow is showing they've got some cross beam across there, which isn't applicable. And then we, again, you know, the cover isn't even on the basin. So again, this is what we're trying to minimize by you indicating in your verbiage what type of cover you want. Access, location, and solutions. When we talk about pits and we talk about industrial applications, Ministry of Labor is very strict, and manpower have limitations as to the weight of any equipment that people have to handle. Our particular pumps from 0.5 horsepower up to 2 horsepower can weigh 80 pounds. It's going to be pretty tough for anybody to deadlift that by themselves. So one of the industry progressions, I guess, we've made, we have a rail system where the pump actually sits on a rail system, and it enables you to bring the pump up and down without removing all the discharge pipe. So on the right-hand side, I'm just showing 2 pumps side by each with a couple of rails. And on the right-hand side, you can see a cutaway version of a tank. And each pump has its check valve. I've circled one of the check valves on the rail that doesn't have a pump. Again, I'm showing you the green arrow where the product is going to be coming into the pump, and then the red arrow on the discharge pipe showing you where it goes. And this red circle, I'm just showing you the discharge valve that's going out. And that's a 3-way valve. There's two ball valves there, 2 shut-off valves, and then a single discharge. So in the second, I'm hoping this again doesn't take up too much bandwidth, but this is this will show you on the left-hand side. Will show you a small grinder pump coming up and down on a rail system. And again, as you can see, we're bringing the pump up. And this would be a 125-pound, 2-horsepower grinder pump. And it's going down the pit. And again, we can go any length of pit, anything over 10, 11 feet, we would put an intermediate bracket in place, and which enable you to have any great length. So the project that I'm currently working on is 6.5 meters deep, and we're going to have 2 intermediate brackets in there. And again,
Stuart,
this is
Stuart,
yes, sir.
don't
Yeah.
play the videos. We'll send them all in an email follow-up to everyone.
Okay.
It's just
Is it jittery or what's happening?
Yeah, the audio is not good when the videos are playing.
Okay, well, I'm just want to play this one, Zach, and then I'll just talk before it, and I'll play it real quick. I just want you to notice, you wonder how the pump seats. On this particular video, on the right-hand side, the pump is very large, and at the very end, you'll see how it seats itself against the base elbow. So again, this pump is suspended about 1 inch or 2 inches above the base of the pit. So when it comes down, the full weight of the pump, and you'll see it, it sort of eases itself into the fitting, and that's how you get your seal. I just really quickly show this. Okay, so that was at the end, you saw that little ease as it moved in, and that's what happens. The way there's a certain angle on that movable fitting, so when it comes down, the pump just automatically moves in and creates the seal.
And that ties to one of the questions from the crowd. Is the rail connection through tapered flanges? I believe so, correct?
I'm sorry, what was that again?
Is the rail connection, does it work via a tapered flange? It's more from like a taper on the actual.
It is. There's
rail,
the
right?
two, yeah, the two faces are machined, and it's not a big angle. It's only, I think, the 18-degree bevel or 18-degree edge. So just enough that, and again, because the pump is suspended, the weight of it just automatically does the seal. And there would be no seal, no issue with a 475-pound pump, and there's no issue down to 25, 30-pound pump. Okay. Now this particular, I've thrown this in to kind of show you the beauty of the way rail systems should be set up in a pit or in an application. On the left-hand side, you can see they've got a couple of upper brackets to a rail assembly. I've got a red dotted line there because that's really where that cross brace should be. And as you can see in the bottom left-hand corner, I've got a picture of a circular tank with that cross beam and the upper rail assembly to it. So that is really the way you would like to set it up, because what happens, as you can see on the right-hand side, we had this application where the mechanical and the civil had a dispute as to who was at the site first. The mechanical came in and did partial of his plumbing. The civil guy came in and put his cover on, and then the plumber came back and finished his piping. And now, as you can see, you can't close the lid on top of the pit. So again, with your instructions, you need to ensure that there's coordination between the civil and the mechanical, so you don't end up having to go to the trailer and negotiate who's at fault and who's going to pay for the proper installation of the equipment. So again, just a heads up. This is what you kind of want. You want to create a solution. Here we had 3 tanks. They're elevated much higher, so we ended up the general contractor ended up putting a mezzanine in where you ended up walking up to the pits. So that way they were able to put the tanks right on the ground. Again, One of the considerations you have to be aware of is confined space, confined entry. Here's a recent job that we've been working on. We're just now actually putting in new product, but this particular product had centrifugal pumps, and you can see them on the left-hand side down in a pit. And the problem was that the pit, as you can see, I've circled it down in the bottom right-hand corner, the pit ended up filling up with water. So now you have centrifugal pumps that are not submersible, are now flooded out because of the water. Also, this particular installation, as you can see, the control panel on the top of that picture on the right, I've circled it. There's no main disconnect on this particular panel. So anybody entering that particular installation is just ripe to get electrocuted. So this was a very, very poor installation. And again, it goes back to, you know, your design consideration and inspection and your directions. If the directions aren't there, they're not going to do it. Here's a couple of solutions we came up with on the left-hand side. We can give you a fiberglass tank in sections. This enables you to put in a 96-inch or 120-inch tank into a building and run it piece by piece through an elevator or through a 36-inch doorway. Each one of those sections could be 36-inch wide, and you can have 4 or 5 sections, create the panel or create the basin inside of the building. On the right-hand side was a conversion we did at Nestle. Again, they had an old existing concrete tank. We're concerned about their storage capabilities because the city came in and wanted them to retain a lot of their processed water, have it tested before they punched it out to the city sewer. So they just changed on the top of that picture, they just changed the inlet locations to come into the top of the tank. And because it was a fiberglass tank, we were able to give them much larger storage capabilities. So again, very simple solution. Don't be limited by what you see. Just be use your imagination, and it's amazing what we can come up with for you. Again, here's just a couple pictures of how neat and tidy a lot of these applications can be versus a lot of applications that end up in the field because we haven't had the proper narrative. One of the other features again of the Zoeller Pump Company is we have a controls division. And again, we are a Canadian control manufacturer. Oddly enough, Zoeller manufactures control panels for all of our competitors. That seems odd, but under our Tulsar controls, we supply panels to a lot of the other manufacturers that are much larger than us because they have product that far exceeds what Zoeller has. But again, one of the important things on the Tulsar side, it is a Canadian-made, manufactured in Brantford, Ontario at our facility. You're going to go through the same controls consideration that the electrical guys are as the mechanical do. So again, here's a very, very quick slide, and I'm sure Zach can make this available for you. This shows how critical the electrical guys are to the mechanical and how critical the mechanical guys are to the electrical. Those 10 points. Like, there's information that you both have to supply, but there's a lot of information that the electrical guy has to supply. So there is that synergy in a lot of the engineering firms. You're lucky if you have the electrical division. You don't want to tell them that because, but you are very fortunate because that will cut down a lot of questions and a lot of speed up a lot of your design considerations. And as you can see, I've indicated the electrical department, what they're responsible for and what the mechanical is responsible for. Again, on the right-hand side, it shows you the typical questions that the control guys are going to ask. So they're going to ask, is it a new panel? Is it a replacement? No different than what we're doing on the pump side. And then they're going to ask you specifically about alarms or audible alerts you want. And if there's any logic, if there's any data, any output that you may want. This is where you're able to design what you want. And one of the big features that we push on the Tulsar side is data. Everybody wants data now. They want cycle times. They want elapsed times. They want maybe indication of what the pump faults are. So these are things that with your design capabilities, we can create for you. Again, we're going to typically use float switches or brackets or float trees. Again, on the left-hand side, just showing you the typical duplex with the level controls extending into the pit. Or your application may require that we use pressure transducers or ultrasonic. And the ultrasonic is where is located at the top, and it's literally taking a beam and beaming it down to the surface to see the level indication. Or the pressure transducer, which is in the right of the picture, which is sitting down the bottom of the pit. And these two particular applications are much more expensive than your typical $50, $60 level control. These are more like in the range of $2,500, but they give you so many options and variations in level control that the floats can't give you. And again, each one is specific to the job that it has to do. Again, some of these aren't good. Ultrasonic may not be great in a sludge buildup, or it may not be good if there's a lot of grease or grit. But again, the ultrasonic versus floats, you might be talking $2,500 difference. So the pressure transducers again are great. You're seeing a lot more of those. And again, they're typically set about 6 or 8 inches off the bottom, so they're not in a lot of the sludge that may gather in the pit. But again, we can give you the different float indications or level indications in your application. One of the considerations. Question, yeah.
So sometimes power availability is limited, but they do still want a second pump for redundancy. Can you talk about the options on the controllers that prohibit both pumps from running simultaneously? Any design changes that you might have to do so?
Typically, in our design criteria, you have a feature called non-concurrent start. So there is not, even if both pumps were signaled to come on at the same time, there is a momentary pause or delay in starting both pumps. You're never going to get both pumps surging on, because you're right, when the pump starts, that's its maximum amperage when it starts up. So there's that momentarily delay. And again, the relays and fuses are timed that they can handle that surge without blowing. So there are ways that we can, because you will have an application where in a duplex application where 2 pumps may want to come on at the same time, and they will, but there's, like I say, there's a couple second delay. So we can do that in the controls and in the fusing.
Perfect. And another question on different ways to manage the levels and whether or not that will affect the depth of the pit. So would an ultrasonic or a pressure transducer allow?
Sorry, Zach, I didn't catch that.
So would a ultrasonic or a pressure transducer allow for a shallower pit? Do the level indicators affect the depth of the pit at all?
Okay, I can't hear that, but what I will, the ultrasonic typically is something you're going to use in a municipal application just because of the cost. The actual control could be 25 to, and I'm being light with this, it could be like $3,000, let's say, versus your level controls, which are readily available. But it's the data that you're able to obtain by using the pressure, by using the or the ultrasonic. The pressure transducer is less expensive, probably a third less, and it too will give you a variety of level indications that you can use. So it's probably in the middle, but Again, the ultrasonic, I think you'd find the ultrasonic is mostly in a municipal application where they're monitoring and they're very diligent on things like cycling, ensuring that they don't get septic systems, ensuring that they don't get grease buildup, ensuring that they don't end up with too much of the product settling out. So I hope that
might not be working very well, but does that affect the depth of the pit?
the depth of the pit, the ultrasonic can handle any depth. If it's a really deep, because of the nature of the enclosure, that ultrasonic doesn't necessarily have to be located at the top of the pit. I've shown it at the top of the pit, representative of it being there, but it could be located lower. But, you know, 6 meter, you could still have a good reading. There are other, you could use radar, which is another feature or another function. We typically are, I would say, of the ultrasonic, most of them are the ones provided by Siemens.
Perfect, thank you. And we just have another minute or so left, so
I'm sorry?
we might have to answer questions as follow-up. So we just have to wrap up in the next minute or so.
Okay. So again, this is, again, enclosures, that's important. The rating, NEMA 7 explosion proof, much different than your NEMA 1. Again, your NEMA 1 is an indoor enclosure. NEMA 4, NEMA 4X might be outdoor. So again, when you're talking about controls, you want to ensure that you know where that location is and designated it appropriately in your verbiage. We also have the ability to give you a circuit board base. This is more of a commodity type product, but typically we go to the electromechanical because this gives us a lot more capability to give you data, give you output, give you functionality, and give you more design criteria. Here's a perfect example. We used a Belleville police jail. They were using 6 2-horsepower reversing grinder pumps. And we have a readout for each pump. And if we had used a circuit board based control platform for this, the panel would have been about 5 times the size of this electromechanical. It ended up being a 30-inch by 30-inch by about 12 inches deep. So a lot tighter configuration, and gives us on the far right-hand side, as you can see, as you can see on the rails, gives us a lot of room and a lot of flexibility to add and subtract. And also, if there was ever a component issue, all those components are readily available from any electrical supply house. Again, specialty controls, we can do NEMA 7 explosion proof, which is a big feature. We also do kiosks, and we can do special custom control painting, as you see on the right-hand side with John Deere. So again, on the startup and commissioning, it's critical that, and we show it, we have the installation, and we also have, which is mechanical based, and we also have the electrical, which are 2 considerations that should be done. And I urge every one of your jobs should have some sort of commissioning report issued. And again, we have the CAD and Revit BIM library, which Zach has provided with the ATS, and they do a lot of our drawings for us. They are on our website, so if you need to have those, please view. If you need one, you just let us know, and we can create a BIM file for you or a Revit file.
And along those lines, you know, with ATS, not just the pump, obviously we can do the full basin, pits, and controls package in Revit as well, so you can have all that metadata built into your Revit file. We can download that in a 2D CAD similar file as well. So if you need that, and then of course all the written specs and PDFs that you need. So for any of your pump projects, please feel free to send that in to ATS, and our spec team, Mo, myself, Stephen at West, will all be able to help you size and select your basin controls package. And then one of the things we've been reiterating and getting a lot more questions with lately is any firm's master files. So if you do need an update to your master specs, or if you're doing a review of that internally, we can definitely get you improved verbiage, provide a second look on that, and we'll get that done for you later. And then just one last question that came in. Does Zoeller send their own technicians to inspect, start up, and test the pumps, or is it relied upon the contractors?
Jack, it's really hard to hear
Sorry,
your audio.
Jack.
Video.
Yeah, sorry. I'll send a follow-up email with all that information.
Okay. Well, I appreciate everyone attending. I hope some of it was informative. I hope that there was a couple of points there that you were able to take away, and sort of reassuring you that you're either doing it right, or you're not doing enough, or you need more help. But we're here to help. Reach out to ATS or reach out to Zoeller ourselves, and we stand behind our product, and we're happy to work with the engineering community. So again, good luck, and thanks very much, and I hope you enjoyed your lunch.
Have a good day, everyone.
Thank you, Stuart.
Okay, sir.